To understand attacks targeting web applications, and more specifically the client side of web applications, that is the internet browser, we need to know a little bit about the browser's protection mechanisms. How the browser protects the host computer from a malicious application, and how the browser prevents the different web applications open in different browser tabs to interact with each other. So this video focuses on browser security. Web browser security, as the name implies, is about security on the client side of a web application. As you know, a browser can run multiple web applications. For example, here's an overview of my browser that is connected to two applications. One is my university's web application. The other is the Reddit application. And there is a tab for each application. Basically, the purpose of web browser security is twofold. Firstly, to protect the computer from malicious code, such as malicious JavaScript code that might be included in downloaded HTML pages. It is also to isolate the content of different applications from each other. Concretely, there should be no interactions between the university's web application and the Reddit application. Let's look at the first protection mechanism, which is the one that protects the computer against malicious code that might be included in HTML pages. To protect the computer against these malicious codes, downloaded scripts run in a sandbox. A sandbox is a security mechanism, an information flow mechanism that restricts the scripts to access the host computer. Basically, the security policy, which is in a way hard-coded in the sandbox mechanism, says that downloaded scripts cannot create or write files. It says also that downloaded scripts can read files, but this is only allowed by letting the user select the file. Now, in order to isolate the content of different web applications, the downloaded scripts are constrained by the so-called same origin policy. This is an important policy to know if you are a web developer. The same origin policy is what we call the mandatory policy. It states that scripts downloaded in the context of a given web application do not have access to data related to another web application. And in fact, most modern browsers enforce this mandatory policy. To help you understand why same origin policy is crucial, consider the following example where one of my browser tabs is connected to my bank account and the other to a website returning an HTML page containing malicious code. If the same origin policy wasn't applied, the malicious script could steal the authentication cookie related to the connection with my bank. And this malicious script could simply order certain fraudulent transactions on my behalf. So let us now look at some details regarding this same origin policy. As you know, you can open multiple pages within a single web application. For example, I can open several pages of my university's website. And if I am asked to authenticate myself, I won't do it every time I open a new page. So in fact, the same origin policy, as the name implies, allows pages from the same origin to share resources such as cookies and the document object model. A browser will only allow the scripts contained in a first page to access data on a second page, if both pages have the same origin. An origin is defined as a combination of a URI scheme, a hostname, and a port number. I will not give the algorithm that calculates the origin of a page. You can refer to this request for comments. I will only show you a few examples that I took from Wikipedia that basically explain everything in a nutshell. So here are some examples of URLs. For each URL in the table, the middle column, the outcome column, indicates whether the URL is from the same origin as the referring URL. So let me show you this referring URL. It is here. Okay? The first two URLs are from the same origin as the referring URL. Same schema, HTTP, same host, example.com, and same port number, same implicit port number, which is, as you know, the port 80, which is the default network port for HTTP. The same goes for the third URL, although it seems a little bit a strange URL, but it has since it has same schema, same host, and same port as the referring URL, both are of the same origin. The next URL is not from the same origin because it uses a different port. It uses port 81. The next one also is not of the same origin because it uses HTTPS instead of HTTP. Okay, so you can read the other examples by yourself. It's very easy to understand. And there is only this last URL which can be a small problem because in fact the outcome will vary from one browser to another. Okay? You may consider that the last URL is of the same origin as the referring URL because it uses the port 80, but here the port is explicitly written, whereas in the referring URL the port is implicit. So some browser will consider the last URL as being of the same origin as the referring URL, but other browser will not. So I hope you now have an idea of what browser security is all about. An attacker who tries to steal an authentication cookie linked to a web application will face restrictions imposed by the sandbox mechanism and the same origin policy. In particular, the attacker will not be able to directly attack a web application from another web application.